Heavy textbooks and memorized paragraphs fail during rapid-fire technical interviews. When the pressure is on and an engineer asks you a direct question, you do not have time to mentally search through hundreds of pages of theory. The solution is a single-page, 5-block cheat sheet. We are going to build a tool designed specifically for rapid recall and practical application on the spot. To start, prepare your workspace. Grab a blank piece of paper right now and physically draw lines to divide it into 5 distinct sections. Limiting your interview prep to a single physical framework forces you to prioritize. It reduces cognitive overload during the actual interview, ensuring you only carry the most critical data into the room. Go to your first section, Block 1. This is for foundational laws. Write down the formula for Ohm's law. V equals I times R, meaning voltage equals current multiplied by resistance. This diagram illustrates Kirchhoff's current law, or KCL. The total current entering a node must exactly equal the current exiting. Expanding outward, we see Kirchhoff's voltage law, or KVL. This rule states the total voltage in any closed loop always equals 0. Next, write down the formula for power factor, cos theta. Power factor is the measure of how efficiently electrical power is being used in a system. A low power factor means high energy loss. The standard industrial solution to fix this is installing a capacitor bank to correct the inefficiency. Immediate, accurate recall of these 3 foundational laws proves your baseline electrical literacy to any hiring manager sitting across the table. Move to Block 2, Heavy Machinery. Start by defining the transformer. It is a static device that alters voltage, stepping it up or down, using mutual induction between coils. Looking at this split-screen comparison, you can see why transformers require alternating current, or AC. AC creates a changing magnetic flux, which is necessary for induction. The system fails on direct current because DC produces a constant, motionless flux. Next is the induction motor, which runs on electromagnetic induction. To understand it, you need to know slip. Slip is the difference between the rotating magnetic field speed and the actual physical speed of the rotor. Look at the layout on screen and write down this precise mathematical formula. Slip equals ns, the synchronous speed, minus nr, the rotor speed, all divided by ns. Add a note on the star delta starter. Its specific mechanical purpose is to safely reduce the massive surge of starting current when a motor first powers on. Mastering machine behavior separates theoretical students from candidates who actually understand real-world industrial physics. Now we move to Block 3, Grid Infrastructure and Safety. First, document the financial and physical rationale for high transmission voltages. Pushing the voltage high lowers the current, which directly lowers the I²R power losses over long distances. Distinguish your measurement tools. A CT measures high currents. A PT measures high voltages. The Megger measures insulation resistance. This ensures wires are safely coated. This diagram outlines the specific engineering functions of the earth connection versus the neutral connection. Neutral is the intended return path for current in a normal circuit. Earth is a dedicated safety mechanism that catches fault currents and drives them into the ground. Confusing a safety ground with a normal return path is a major red flag that will immediately disqualify a candidate in a technical interview. Move on to Block 4, Diagnostic Logic. Interviewers will test your mindset with practical scenarios, starting with, what do you check if a motor won't start? This flowchart tracks your exact diagnostic sequence. First, check the main power supply. Second, check for a blown fuse or a tripped MCB, a miniature circuit breaker. Third, inspect for physical winding damage. Finally, check if an overload condition tripped the relay. The second failure scenario is diagnosing an actively overheating motor. Following the new branches on the chart, there are 3 checks: an overload causing excessive current draw, low voltage forcing the motor to work harder, or a cooling problem like a blocked fan. Reciting a structured, step-by-step troubleshooting list proves to the interviewer that you are a safe, methodical technician rather than a guesser. Finally, move to Block 5. This section is designed to bypass the psychological traps of standard HR questions, starting with the notorious "tell me about yourself." Use the exact template shown on screen. I am name, an electrical engineering diploma student. I have a specific interest in machine interest and practical troubleshooting. I am a fast learner and I believe in strong teamwork. Next, address the secondary trap. What is your greatest weakness? Write down the specific pivot script. State that your weakness is occasionally overthinking problems. but that you are actively mitigating it by applying strict time management improvements. Practicing this exact pre-written script prevents nervous rambling and immediately frames you as confident and self-aware. Take a look at your completed sheet against this final reference to confirm you have all 5 blocks filled out accurately. You now possess a holistic interview playbook. Your mandatory homework is simple. Read this single page out loud 3 times before you step foot into the interview room. This single piece of paper provides the exact bridge needed to translate theoretical diploma knowledge into practical, hireable confidence.